All right, what is up, play-by programmers? Today we're going to be getting back into some behavior basics for Desynced, doing some visual scripting here. We're going to be talking about flow control today. So I think I sort of jumped the gun with the last video from a few days ago, sharing a behavior with you all. And I don't actually think I want that to be in the behavior basics playlist. So what I'm going to do is I'm probably going to move that over to a behavior share playlist. And then I'm going to put this as the new part 7 of behavior basics. Because I think there's a lot of stuff to still go through. I started looking at this flow control stuff, and there's even 2 or 3 videos just in flow control. So today's going to be part 1 of that. And we're going to look at some of the ways that you can manipulate the path that your behavior is taking so that you can do different things based on how the data plays out in your behavior. So let's take a look at the first one here. You'll see is compare number. Now, there are lots of different compares. Because this is behavior basics, we're just going to look at one type of compare. Just know that there are lots of different comparators in this visual scripting language. They all work mostly in the same way, although the number one is much easier to deal with. Some of the rest of these are a little finicky because of the way variables work in Desynced. And because those variables can have sort of lots of different information, like an ID plus a coordinate plus a number, they can be pointers to different units. They can be a bunch of stuff like that. So some of these get a little finicky to work with. So just know that if something isn't coming out the way you expect it to, you're just going to need to fiddle with it a little bit. And I'll show you kind of what I do when I'm trying to troubleshoot that here real quick. So let's go into my Scout. My Scout actually should have here it is. This is the thing that I'm trying to look at here. So this will allow us to do what I normally do. So the first thing we're going to look at is we're going to look at compare number. Now, compare number is really important because it just compares the number value in a variable to another number value in another variable. So all it's going to look at is the number part of your variable. So you'll see here that we have 10 being compared to a null value. In this situation, the null value is going to act as a 0. So if we go through and we just step through this real quick, you'll see that 10 is larger than 0, so we're going to go to the 10. We're going to go to the larger here. And that's the path we're going to follow. So I can change what these values are, and that will change what happens here. But let's even look at, let's take a look at this, and let's turn this into a 10 plus an identifier. And we're still just worried about the numbers here. So when we do that again, we still just get that larger value. We could even turn this. What I'm doing here to show all of these options is I'm hitting Control and left clicking. And that's giving me everything. If I just left click, it kind of limits me just to what it's able to take in. So it's just giving me these numbers and then all my variables and stuff here. But if you control click, it'll give you a lot more. So the other thing I can do is I can actually add a metal ore with no number, and that should still operate as a 0, and it does. So if you want to compare like, does this building over here have more ore than this other building over here or something like that, you can absolutely do that without separating these, but that's not always the case with every comparator. So just be prepared for that. So the other thing we're going to look at here is it does actually recognize negative numbers as well. So if I put negative is smaller than 0. So we can go through, we'll go down to the smaller. And then if I go ahead and turn this one to a negative, then we'll go down this other path that's equal here. So this is really important because it's going to give you the opportunity to do different things based on how that data is shaking out, and allow you to sort of break off your program, right? If the values are equal, maybe you don't want to do anything. Let's take that example from before, where maybe we're checking how many resources two different buildings have. If they have the same number of resources, maybe we don't want to do anything. If this one, right, this starter value has more resources than this one, maybe we want to go ahead and send some resources over to that other one. And then if it has less, maybe we want to get some resources from that other one or something like that. So that's really what a comparator is for. It's just kind of a way to choose between a few different options based on the input data. So that's kind of your first flow control. So let's move that out of my way here. And then let's get a sequence. So the next bit of flow control that we want to look at here, need to zoom out. The next bit of flow control that we want to look at here is a sequence. Now, this is a switch, not a sequence. Whoops. That's fine. We'll talk about switches. So a switch is sort of like a comparator, except you're not comparing the data and then choosing what option to do. Instead, you're looking at the data, and then based on what that data value is, you're doing something different, right? So if I get an input, maybe I'm looking at what's in an inventory, and I look in the inventory slot, and I see that inside of that inventory slot, there is some metal ore. And I want to say, okay, well, if that slot has metal ore, then I want to go ahead and produce some metal bars. And so then I would set case 1 here to metal ore. So it's really kind of like a bunch of matches, right? So the input checks all of your cases to see if it matches a case. And then if it does match that case, then it chooses that path to go down. And then your default path is just if none of the cases exist. So if this was null here, so there's no value, it's going to go down the default. So actually, even though that's an interesting thing to look at, even though that null value technically matches with these null values down here, null values in your case don't matter. So it just follows that default path. But then if I change this value instead to be this metal ore, then when I go, it'll actually go to case 1 here, right? Output 1, because this is case 1. So this is a really good way to just do a series of matching, and then based on the data that you're getting input, choosing to do something. So I've got crystal down here. So maybe I want to make metal bars if this is metal ore. And then maybe instead, when I get crystal, maybe I want to go ahead and make some circuit boards or something like that. And so then when I check that, boom, we'll go to situation 2 here. Now this only really works with IDs. It doesn't work with numbers and stuff. So if we add a 1 there, and then we input a 1 instead, you're going to see here that it still goes to the default. So it only uses these visual IDs. It doesn't use numbers as part of its match. So that's just another one of those kind of finicky things you're going to have to kind of work with and figure out. But you can always just do a little guess and checking. As long as you've got this view current values up right here, that lets you see any of your variables, what their actual values are. And that really, really helps when it comes to figuring out where it is that you're your program is going a little long. So always just step through and take a look. You don't want to just hit play, right? You want to go one step at a time just to make sure that things are going well. All right, but that's switches. Switches are pretty easy. If you have more than 5 cases, you can absolutely just add another switch onto this default. But I actually discovered a way to make an infinite switch the other day, and we're going to talk about that on another video when we look at labels and jumps. But you can just add another switch onto the end of this default. If you had maybe 10 different cases you wanted to look at, you could nest those switches, and that would work just fine. But yeah, that's pretty much it for switches. They're pretty powerful, they're pretty useful, and they're going to help you clean up your code quite a bit. We'll go ahead and move that over here, and then we'll go grab, let's see, we want to do sequences, I think. Sequences are kind of interesting. I think this is probably the one that has the fewest use cases, other than just prettying up your code. So the thing about sequences is you'll see here you've got first, second, third, fourth, last. And what this means is that it's going to do each of these bits of code in sequence. So it'll do all of the first bit of code, and then it'll jump back, and then it'll do all the second bit of code, and then it'll jump back, and then it'll do all the third, all the fourth, all the fifth. And you can even nest these, right? If I had more than 5 things, I could nest another sequence on this last right here. And then that would allow me to do all of that in sequence also. Or I could put a sequence on each of these and do, 5 different in sequence operations in all 5 of these little things here, little outputs. So there's lots of ways that you can kind of pretty up your code. The only time that this would really function, not just as a way to pretty the code, but also as a way to simplify your code, would be in a situation where you wanted to get data from different operations, but then you wanted to conduct the same manipulations to that data. So for example, if I wanted to get the specific data type of whatever I was getting in all of these, there's a couple of different ways you can get data. You can get data from the component. So I've got here, you'll see, let's save this. When I go through first, I'm going to get the data from my component integrated behavior controller, and I'm going to get it from parameter 1, which is going to give me this OR value. And so when I go through there, why is it not giving me my OR value? What are you doing? Well, that's weird. But anyway, so this is one way to get, oh, it's because I didn't set it up. Never mind. I get it now. So one of the things that happens is when you hit this view current values, it takes away the fact that there's a variable there. So I thought I had made a variable there, and I hadn't. So now when we do it, it'll tell us, okay, it gave us that OR value. And so that's one way that I could get some data, and then I could check the type of that data. But then if I also wanted to get some more data from some other way and do this same type check on it, then I could use, as a second here, I could do get closest unit, and then I could also just do the type check. Now this can totally be done just in a line, right? I can do get from component, type check, get closest unit, type check. But the longer this little bit of code here is, right, if it sticks out a ways, then the more and more code I'm having to duplicate, and the longer and longer my code is going to get, and it's going to make it a little more difficult to read, and it's going to make me have to duplicate a lot of code. But if I do it with this sequence thing, then I can just do it all right here, and I can kind of keep track a little bit better. And then I don't have to duplicate any of this code. So sequences are really about prettying things up. It's got a pretty limited use case when it comes to stuff that you can't do any other way. But it is a super valuable thing to get to know. And then the last thing we're going to look at here is we're going to look at loops. So loops are honestly probably one of the things you're going to use the most. And just like comparators, loops have lots of different types. And so, so we're going to look at loop number, which is the most basic type because this is behavior basics. But we have lots of different types of loops that you will probably want to use for lots of different things. So let's just get a basic understanding of how loops work. And then you'll be able to apply that understanding to all these others. And then you'll be able to do the same as with the comparator, do a little guess and check, see how things shake out by using this view current values button and stepping through your code. And you should be able to figure it out. I believe in you all. So let's take a little look here. If we look at loop number, we're going to start with from. So this is our starting value. And then we're going to go to, this is the final value. And then our step here tells us how many numbers to add to our value each time we go through the loop. So we'll start at 1. And then every time we come back to the beginning of the loop, we'll add 1 to that number. And then it outputs whatever number we're on as this value right here. So we'll kind of show how that works. If we step through here, you'll see we started a value of 1. And now I've moved this variable up here to combine register. And so I'm now combining our loop index number with our integrated behavior controller. And so when we push that through, you're going to see now we have integrated behavior controller with an assigned number 1. And then we're going to get from our component our integrated behavior controller with our assigned index 1, which means we're going to get this value right here. And then we're going to push that, and now we have a value for that. And so then when we go forward, now we're going to go back to the beginning of the loop. And you're going to see this value has stepped up 1 to value 2. And so now when we combine this register, we get integrated behavior controller with a number 2, which actually puts us up here at parameter 2. And so when we run this node, we get the value that's in parameter 2, which is crystal 1. And then we go back, and now we're in value 3. And so now we're going to go to integrated behavior controller 3, and we're going to get its value, and we're going to get silica 1, because that's the value in parameter 3. And then we go back, and now we're on our final step, which is 4. And so now we're going to make this a 4 here, and then we're going to get that value, and now we have metal bar 1, because that's the value in that parameter. And now when I go back, it's going to restart, because I'm going to be done. And so whenever you finish your loop, let's actually get some more stuff here. Once your loop is finished, you actually carry on with the code through this done loop here. And I'm just going to copy paste this a couple of times just so we can step through it a little bit. But we'll hit a save right there, and then we'll step through. So we've got our 1, we've got our 2, we've got our 3, we've got our 4. And now when we go, we're going to move down to the done because we got to our 2 value. If we had put this all the way up at 10, we would have kept going all the way through 10 times. Or if we had started at 0 and done step 2, we would have only gone through it twice. So all of these number values can be variables. So you can do all kinds of interesting stuff to decide where your loop is starting and where your loop is ending and what sort of increment you want to go by. And it's not just for reading parameters, it can be used for all kinds of different things. But for now, we're using it just as an example on these parameters. And so then we're doing this done stuff, right? So we've gotten all of this information here from all of our parameters. We could have done a bunch of stuff to it and then saved it to different variables. And then once we've gotten all that done, we could have come down here and we could have used all those variables to do a bunch of different stuff after we finished that loop. Or if all we needed to do was loop through and get that information to like save it to an array or something, then we could have left this done variable empty and then the behavior just would have restarted because this would have been the dead end of the behavior. So all kinds of different things you can do with loops, all kinds of different things you can do with the different kinds of loops. The loops are honestly a really big deal. I think loops and switches are probably going to be the things you use the most. Compare and switch is probably going to be pretty similar because they serve a similar function. This is more of a matching compare, and this is more of comparing two values. But these are both pretty important. And then sequences, honestly, you're going to start using these the bigger your behaviors get. But until your behaviors start getting pretty large, you're probably not going to use them a ton. But yeah, this is flow control. This is how you affect your code and how you control. It's really aptly named, right? It's how you control the flow of your program as it passes through these lines, through these nodes, from one to the next to the next. So very, very important stuff to understand. Like I said, we're going to do a couple more flow control videos because you'll be able to see if you look over here, just in this flow, we've got calls, we've got parameter events, we've got exits and breaks, and checking if things are empty. We've got jumps, we've got labels. We got all kinds of things in here to look at. So we're going to do another 1 or 2 videos on flow control, probably at least 2. And that'll give us a better understanding of how to manipulate some of our data. So I hope everybody got some value out of the video today. If you did, don't forget to hit that like and subscribe button, and I will see you all on the next one.